And with that, I will stop sharing and introduce tonight's speaker, Ben, who is an architect with 25 years of experience on projects across the United States. He is the founder of Waechter Architecture, which was established in 2008. A native of Oregon, Ben first apprenticed with his grandfathers, who are an architect and a builder, and his complementary passions, nature and construction, have shaped his career ever since. To date, Wechter's professional experience includes a range of building types, including cultural, hospitality, commercial, multifamily, affordable housing, and single family residential. And with that, I will turn it over to you tonight, Ben, and thank you for being our presenter.
My pleasure. Thank you, Heather. And I will share my screen here, hopefully. Does that look like it's working?
Looks good.
Looks good. Okay. So yeah, tonight I'll be presenting two projects that were recently completed. One, what we call the Mississippi Workshop, and the other, Rockwood Village. They're both very different projects, but there are some themes that I'll talk about tonight. The first one, Mississippi Workshop, that's a smaller project. It's about just under 10,000 square feet. It's the first all mass timber building in our area, and it's our studio, and it's also my residence. And there's also there's a coffee shop on the ground floor. Rockwood Village, in contrast, is it's an affordable housing project in Rockwood and Gresham. It's 244 units, and so I'll talk about that secondly. But before doing that, I'd like to just introduce you to our studio. These are the people in our studio in the Mississippi Workshop building, the all mass timber building. And also talk about our approach as a studio. And I think one way we like to describe it is an idea of clarity. And what we mean by clarity is it's essentially experiential legibility. And that legibility starts as a formal legibility, but then it's also compositional legibility, material palette legibility, systems legibility, and so on. I oftentimes start with these images, and I like these images because, to me at least, they represent formal legibility, and I like them also because it demonstrates how formal legibility can occur in all types of places. So on the left is Ibn Tulun Mosque in Cairo. So legibility within an old city that's been built up and built over for a very long time. It can happen in newer cities like New York, and the legibility of the grid between the East River and the Hudson. It can be a formal legibility of a hill town. So this is Bryn. It's a Swiss hill town, and how the buildings of the town group together and form the legibility of the village itself. And then, of course, legibility, experiential legibility, occurs in nature all the time. And this is one example, a meadow in Central Oregon. And so these are the two projects, Mississippi Workshop and Rockwood Village. I'll talk about Mississippi first. I have I think quite a few more images with Mississippi than Rockwood, just because we've been doing a number of projects with it. But I wanted to start with these two diagrams. And so we always start with an organizational strategy for a project, whether it's large like Rockwood Village or smaller like the Mississippi Workshop. And it's a starting point for us to help us make decisions along the way. And so Mississippi Workshop, I'll get into it, but the idea was to have a legible form, but also maybe for the first time, have a really strong constructional and material legibility. So instead of building a building with a wall assembly of 20 components, we're building a building with a wall assembly of 3 components or 4 components, that type of thing. And then with Rockwood Village, when I talk about that, it follows this diagram where we're using the buildings themselves as really a secondary element within the project and treating the buildings as an edge to the park. So really giving priority to the park and the buildings as a quiet backdrop to the park. So the Mississippi Workshop, as I mentioned, the idea with Mississippi actually didn't start with all mass timber. It was really an idea of trying to choose a material that we could use, if not in whole, like a building made out of one material, a building that could be made primarily out of one material. And so, you know, it could have been brick, it could have been concrete, but we, because of where we are, because of the time in our world, and because of all of the new work that's been done around mass timber, we really leaned into using mass timber as this idea for one material. This was a model, so this is we built this model before construction, after designing it to really frame the project. And so this shows, so it starts to show the components of the building. It's a 3-story building. It's a courtyard building, and the mass timber walls are constructed as a tilt up. So the walls go foundation to roof about 45 feet with beams at it, as you can see here in the model, second, and then floors third. And then this is a construction photo, so showing well what it looked like during construction. You can see the walls, and these walls again go from foundation to roof, the floors, and then the beams. The beams span about 30 feet from wall to wall, so no columns. This is an image of the same room, but finished with, and this is our office space, or one part of our office space. Context, so we call it the Mississippi Workshop because we're on Mississippi Avenue, which probably most of you know. It's we're at the north end, so Skidmore in Mississippi. It's a 50 by 100 lot. The history of or the architectural history of Mississippi Avenue it's really made up of streetcar era buildings. So whether it's wood or brick, buildings that oftentimes had retail on the ground floor and residential above, strong grid composition of the facades. Buildings also were not, they were smaller scales, so 25 feet wide to 50 feet wide. Some other examples, strong grid compositions. And then a view from the air, so looking down at the Mississippi Workshop. It's clad with weathering steel, as you can see, and you can see its position on Mississippi relative to downtown. View of the front. I'll just mention it now, but on the rooftop we do have a penthouse, so that's the elevator overrun and a stair accessing the roof, but it's also a mechanical room, and on the top are heat pumps. And so the building, it's an all-electric building. It's heated and cooled hydronically, and so we have 4 heat pumps that you can see here. You normally can't see them, but from the air you can see them. And so those are either in heating mode or cooling mode, sending hot water or cold water to the slabs. that are on top of the CLT floor structure. Organization. So organization was sort of a counterpoint to this idea of building all out of mass timber, or all out of one material. And organization was really important in this building as a way of future-proofing it. So the building all out of mass timber was great in the sense of creating this constructional legibility. It was great for creating a strong sense of character and identity for the building and the interior rooms, but it's not easy to change over time. And so we developed a strategy. Basically, we call it 6 rooms, and it's 3 on the west side, 3 rooms on the east side with a connecting courtyard in the middle. And the courtyard's really, the first room or the 7th room. And the idea with this strategy is that each of these rooms, they're larger rooms, about 30 feet wide by 50 feet long, are basically in some ways generic loft spaces, but they've all been outfitted with plumbing and mechanical and electrical to be outfitted with either an office space, an apartment space, or on the ground floor, a commercial space. This is kind of a conceptual diagram, the blue being residential, the orange being office, and the red being commercial. And so this is the current organization of the building. I have an apartment on the 3rd floor, so residential. Our office, our studio is on the 2nd floor, and then there's a Capitola Coffee, a coffee shop is on the ground floor of the west side, and then we have our event space and workshop model making shop on the east side of the courtyard. And this just sort of shows how it could be changed if needed over time, with minimal effort to all apartment, or actually all office rather, or all apartment and coffee shop, or all office, and on the west side all apartments on the east side. More options. This is a ground floor plan of how it's arranged right now. As I mentioned, the courtyard, we really think of that as the first of the 7 rooms, and you enter the courtyard first through a portal. So from Mississippi, there are no doors to the building. You first enter through this portal into the sort of living room of the building, the courtyard, and then from there you enter into the coffee shop or the workshop, or the stairs or elevator to go upstairs. Here's some images of the portal on the right, and then just some images of the courtyard on the left. Coffee shop. Some more images of the courtyard with our model shop and workshop in the beyond. Model shop. And then this is the 2nd floor, our office space. We, on the east side, the right side is our desks, and on the left side, the west side, is our meeting side and kitchenette. And then there's a connecting hallway that connects them, and off of that, the bathrooms, elevator, and stair. But the idea, again, it's generic, and so it's really furniture that's defining the function and use. Some images of the office space. And then the 3rd floor, which is currently residential, or my apartment. So it looks something like this. But again, the body or the vessel of the room, it's the same. It's really just the furniture that's defining or helping to further define the character. Material systems. So this is a diagram of all the parts and pieces, the CLT components. On the lower left, you can see them all together, and the exploded axon is showing how it all goes together. We worked with KPFF as the engineers on the project, so they developed this system that I usually refer to as a tilt-up system. It was installed similar to a concrete tilt-up. So as I mentioned before, the panels go foundation to roof, the 45 feet. Narrow panels between windows, and then spandrel panels filling in. Some shots of the glue lamp. So KLH was the manufacturer, and one reason we went with them is they were able to supply every component of the building. So the wall panels, the floor panels, but also the glue lamp beams. They also made the stair, which I'll show a little bit later. And here you can see the beams being sanded, and then the ends, they're routed out, and the routed out part will be where the Rikon connector, the concealed steel connector, will go. And they were able to connect one half of the Rikon connector in the factory, and then sent the other half loose that we attached to the wall. CLT panel being fabricated and then shipping. Some construction photos. This is basically a diagram showing the sequence of construction of the CLT component. So after the steel, or after the concrete foundation was completed, a mobile crane was brought. We had a mobile crane on site for 2 days, and the first day was lifting up the southern panels that the lot, it's a zero lot line situation, and on the south side is Mississippi Lofts that also is built on the lot line. So building the south walls was the trickiest part. So we basically had the wall. There's 4 wall panels that are each about 7 feet wide by 45 feet tall that were laid down and stitched together on the ground. We waterproofed it, insulated it, and put the metal cladding on it prior to tilting them up. And then this mobile crane tilted them up. After that, the mobile crane installed a sort of smaller tower crane in the courtyard. And we used the tower crane then to install all the other CLT components. So this is showing the more slender CLT panels between the windows, and those are about 3.5 feet wide by that 45 feet tall length. Spandrel panels went in next with a half lap connection. Then beams and floors were lifted into place, or lowered into place. And then that was the west side that was completed first. Then the connector and hallway, elevator shaft, stair, that was done second. And then the east side was done third. And then the mobile crane came back and took away that tower crane. This is a early view of the site. So you can see Mississippi Lofts on the right-hand side. The lot line that we built up against. There's an alley towards the east, towards the back of the property. Here's an aerial view showing those 2 panels I was describing being stitched together, and then waterproofed, insulated, and clad with metal prior to being tilted up. You can see the mobile crane parked on the street to the right, tilting up the panels, and then jumping ahead. The tower cranes installed, and you can see how the panels are coming together on the west side. then starting to install the connector piece. You can also, weather was an issue for us. This was built, or the CLT portion did go up in the fall and part of the winter, unfortunately. And so we constructed this temporary, you can see it on the right-hand side, temporary roof so that we could install the permanent roof underneath. Once that roof was done, well, anyway, once that roof was done, then we moved the temporary roof to the east side. Systems integration. So our strategy for systems integration was to basically create poche spaces or smaller rooms and vertical chases that could connect systems vertically in the building. So the gray portions that are shown here in the plan, in this generic plan, are where that happens. And so we're using the south side, the side that adjoins Mississippi Lofts, the south side of each room for that. So that's where we're pulling fresh air in from the roof. We have hydronic lines running up and down. We have electrical and data. The connector bar where the stair and elevator are, we're running. We have vertical chase there doing the same thing. These are some diagrams of how we're running the system. So the hydronic system there's a diagram on the left. So it's showing heat pumps that you saw from the photo earlier on the roof, sending either heated or cooled water to holding tanks in the mechanical room, and then from there pumping it to the slabs in each of the 6 rooms. And then the middle image shows using the poche space in a similar way, but this is for ventilation, so bringing fresh air in on the south side and then exhausting the air on the north side where the hallway connector piece is. And then on the diagram on the right-hand side is power and data. So we're running, in our case, we decided to run all hydronic systems, all power and data within a 4-inch topping slab. So using the topping slab as a thermal mass for heating and cooling, but also using that thickness to run conduit for power and data. There's a view on the right-hand side of the heat pumps, the view of the roof. On the left-hand side is our mechanical room on the roof, and running some of the hydronic piping. The view on the right, so the main rooms don't have any visible ductwork in the poche space in these smaller rooms that, well, I'm actually happen to be sitting right now in this room where this photo is taking place. So this room does have that I'm sitting in, does have ductwork above it, and then it basically enters the room through a reveal that I think I can point out later. This is showing some of the shaft spaces between there before they were closed up on the left-hand side, running radiant hydronic, and you can see kind of the cobweb of hydronic tubes and conduit. But the idea is from this room, you can change out, you can pull power and data through this conduit, so it can be redone later. This is also where you access the manifold and electrical panel. And then on the right, that's just showing power and data. Here's some of the radiant tubes and power data. We have a sound mat between the CLT structure and the slab, and the green that you see is the sound mat for rotogloss. And then the finished slab looks something like this. And this is kind of I call it the temporary kitchen, which is now our permanent kitchen. But this is showing how the south side of these big rooms can kind of plug and play a kitchen or kitchenette if desired, or it can be removed. Construction details. I'll go through just a series of construction details. This is a detail showing how we connected the long CLT wall panels to the foundation. So the we use the 6x6 steel angle we first basically connected to the concrete with with threaded rod and nuts, and then we lifted the CLT panel onto that, and then the CLT panel was screwed. You can see holes in the 6x6 angle. The CLT panel was basically attached to the angle with all those screw holes. On the right hand side, you can see we used a rubber gasket also from Rotoblas that created a seal, and also just a moisture barrier between the steel and the wood. On the shorter walls, the walls between the windows, the walls that are about 3.5 feet wide, those are more robust shear panels because they're so with hold downs because of the narrowness. And so our hold downs basically took the form of these U-shaped, using the same 6x6 angle, but in the form of a U. So the bottom portion connecting it to the foundation, and then the two sides acting as hold downs. Some installation photos. So we used a half lap. We used a half lap for everywhere really. And so this shows how that half lap, the detail on the right, how that worked. Or picture on the right. It's screwed then together. For the exterior walls, the screws are all on the outside, so they're all concealed by the waterproofing and insulation and metal cladding. So the inside you don't see any screws. This is that Rikon connector that I mentioned from KLH's factory. So KLH installed the middle top picture. The beam came like that from the factory, so that side of the Rikon connector was pre-attached, saving time. And then in the field, the other side was attached to the wall, and then the right hand picture shows how the beam was slid down and the two Rikon connectors joined together. Here's a view of just bringing these beams in. I guess a small interesting thing for those who are interested, or small detail is, I was always concerned with the tight tolerances, with a 3-story building, how we would lower the beams into this tight box and also the floor panels in this tight box. And the technique that the heavy timber installers used was basically taking the steel braces, and you can see the steel braces in this picture, similar to what you would see in a concrete tilt-up, but they would basically, and you can rotate the telescope, so you can rotate the brace and slightly open up the walls or slightly close down the walls. And so when they're lifting the beams down or the floor panels down, they would slightly open up the wall, and then right when the beam's setting in, they would close it. And that was a simple but effective technique. This is an image of the elevator core. So maybe, I don't know if it's the first wooden elevator core in Oregon, but it's one of the few. The biggest challenge for us was the fact that we wanted CLT panels to cover the front of the elevator. So, as most of you know, to install the elevator, the entire opening needs to be accessible for the elevator company. The picture on the left. And so, and this was done well after the crane or any sort of heavy lifting equipment was gone. And so we had big CLT panels laying around the job site that eventually had to go in. And I don't have any pictures of it, but we ended up using, well, a lot of strong people, and then also hoists, and so they were sort of hoisted into position. This is the stair, so KLH also made the stair in components. The tread and risers were pre-installed onto a CLT stringer as one component. The landings were another component, and then the railings were a third component. And you can see an image of it on the right-hand side there. I guess I'll also to mention with the stair, we held it off 3 inches from the sort of volume of the stair or the shaft of the stair room, and we did that for building tolerances, but also aesthetics and also for seismic. And so the stair is really meant to, in a seismic event, be one thing, grouped together as one thing. So it's structurally one thing, and it sits on those steel angles that you see in the picture on the right. It sits on them in a way that they can slide. So in a seismic event, they have some room to slide back and forth and not break itself apart. The last year, or maybe a little more than that, we received a wood innovation grant from the U.S. Forestry Service. It's a grant that's typically awarded to trying to get timber projects off the ground, research and pre-construction development type things. We received it as a post-occupancy grant, and so the idea was to basically do 2 parts. One, the first part being a documentation of what we did, and these are some of the details. It's in the works, it's in progress, but these are some of the details that we're doing to document the current building. We're also working with the University of Oregon, Mark Fretz and his group there, doing testing on the building. So we've done acoustic testing on the building. We've also done thermal testing, thermal imaging, looking at how well the half lap seals work, how much energy transfer there is through that at the corners, from floor to floor, that type of thing. Some more images of that. And then also air quality testing, so testing for formaldehydes. Fortunately, we tested 0 for formaldehydes, but also CO2 quality. And then, yeah, just a few images of life of the building before I move on to Rockwood Village. And so courtyard on the right, you can see the passageway that you go through. A couple people skeptical about if they should enter. Coffee shop image, the workshop. We also we're trying to host as many events in the courtyard. So really, the courtyard is meant to be a space for the coffee shop to use and for us to use, but it's also kind of an invitation to the neighborhood and really the city. And this is a performance, well, Third Angle hosted this performance in the space. We've also Wildcraft, who they organize crafting workshops and classes. They use the courtyard. They've been using in the courtyard this past year, and they'll be using it a lot more in the coming year, the workshop as well. We've hosted events. This was a timber talk we did, and then just some other images. Okay.
Ben, real quick. There are a couple questions. Do you want to answer them now or wait until the end?
Yeah, if it's okay with everybody, let's wait till the end. And I have not nearly as many images for Rockwood, so
Okay.
So don't get concerned, everybody. Let's see here. So Rockwood. So again, it's a different idea, but our starting point was the same as far as coming up with a strong organizational idea. And so the organizational idea or experiential legibility idea for Mississippi was the 6 rooms with the courtyard and then building out of one material. The idea with Rockwood is, how can we create multifamily dwellings in a way that also maintains a lot of outdoor space. And so what we did with this project was really starting with the idea of a park. And the idea with that was sort of twofold. One, or maybe threefold, not to get too deep in the weeds on this, but it was, and we work, this is the developer, it's CDP, so Community Development Partners, and Hacienda CDC were the developers. And they were interested in this site. It was a site that had an open space overlay designation, so it didn't allow for any housing. And so we needed to come up with an idea or concept that that worked to meet the intent of the open space overlay. And so we worked closely with the planners, the Gresham planners, to sort of develop this. But the idea was to take this parcel of land that had an open space overlay, but actually happened to be not publicly accessible, and organize the buildings in a way where they could create a publicly accessible park, essentially. And so the green that goes through the site, the diagram or the site or the neighborhood plan on the right, that's 185th. So 185th, it was basically a super block, and 185th didn't go through. So that was one move, is to make it accessible with completing 185th. And then the second move was really to take the program, these 244 units, and kind of push them as far to the edge as possible. We placed the parking on the outside, so we called that the loop, because there's also a trail, kind of a walking trail you can use, but placing the parking on the outside and then creating a really safe pedestrian-oriented park in the middle. So that was sort of the idea, or the kind of the sort of experiential legible idea, or the sort of clarity idea that we helped develop, or we developed alongside with the planners, the Gresham planners, and then we're successful in getting through design review. The other really great thing about the project, aside from making a great neighborhood park, is it really ended up connecting, from an urbanistic point of view, ended up connecting these other 2 public spaces that previously weren't well connected. So Vance Park, which is a natural park to the east, and then the new Rockwood Rising development, which is more of mixed use, plaza, transit hub development. So all of a sudden, by doing this sort of publicly accessible outdoor space in the middle, we were able to link them all together and help the neighborhood in that way. We worked with Place Landscape Architects, so they developed the site plan. This is kind of an aerial view showing the perimeter buildings. We have a community building in the center, so that's offices, but also community kitchen, community space. This is showing south entrance is on the right, and north entrance to the left. And that's it, showing the 185th street so that did not exist before. So that's how we got into the site. And then just some images of kind of a drop-off area and Plaza Beyond. Some other images of the building. This is typical. It's geared for families, and so it's a mixture from 1 bedrooms to 4 bedrooms. And this just shows that mix. Some images of the top view, or I guess the left view is a 1 bedroom version where the kitchen is part of living, dining, kitchen. The right hand side shows a three bedroom where the kitchen is tucked to the side. And then, yeah, just some more views of the exterior. One thing that, Gresham, the planners at Gresham, one of their big concerns was just articulation and having these big, long, basically uninterrupted facades for building lengths. And, of course, we wanted to do that to make the park as big as possible. But it was a concern. And so one strategy, aside from the recessed windows, was to develop this vertical batten system so it's a hardy, it's a cost-effective wall assembly, but we wanted to have shadow relief and texture, and so it's a hardy panel for the cladding, but then we're using a metal batten, vertical batten that comes out about 4 inches, and so that creates shadow relief. And then at every floor level, we have a metal kind of skirt, and the skirt and the batten work together to create shadow relief and texture, but also the skirt also allowed us to basically put conventional vents behind it. So bathroom vents, kitchen hood vents, all of that stuff exits the building in a concealed way between the skirt. So that allows, so instead of doing the more expensive venting through the roof and wanting to avoid, ugly vents on the wall, this is sort of our strategy for it. And also to create the shadow relief and texture that these long facades really needed. Some more views. And I think evening view. We were able to maintain, there's a great stand of these old fir trees, so we incorporated that into the park, as part of the park. Just some opening day images. And that's it. So yeah, now would be a good time for the questions. And maybe I will exit out of.
So in the chat, I believe these 3 are for your Mississippi project. The first 2 are related to the slabs. Are the heated slabs gypsum based, concrete, or standard?
Standard concrete.
They're standard. And then related, how thick is the topping slab? Is CLT3 ply?
We use 3-ply between the ground floor and the second floor, because both commercial uses, and then we're using 5-ply, not for structural reason, but just for fire rating between the second and third floor.
And then the third one was, how many hours of direct sunlight does the courtyard receive? I don't know if that was for Mississippi or for Rockwood.
Yeah, it'd be a big difference. Well, the Mississippi one, how many hours? Well, it depends on the time of year, of course. Plenty, is that yeah, I don't know what the intention of the question was, but it does, it gets plenty of sunlight, and it's the pictures. Well, some of the pictures showed we have a planter. There's a number of planters in it, and so it's evolving over time. But it's good. It's good, and it has a good amount of sunlight. It's also great in the summertime because it has a good amount of shade. So it's sort of both.
Jay, excuse me, Jay clarified it. Just wondering how much the 4-story building due south was impacting that project.
From a sun point of view.
Yes.
Well, quite a bit. I mean, if it's, I mean, we just, if the building to the south is approximately the same height, so it's all about 45 feet. That's on Mississippi. That's the height limit. So it's somewhere around 45 feet. So it's really, and the courtyard itself is 40 feet by about 30, 35 feet, something like that. So it's almost, and it's 45 feet tall, so it's a little taller than wide. But it hasn't, the south building hasn't impacted it in a bad way. It's nice. I mean, it feels like a room essentially, and certainly gets plenty of light, and then depending on the time of day, gets a good amount of direct sunlight.
Everything else in here looks to be just people saying how wonderful everything looks and what great presentation it is. So just so you know, if anyone has any questions and they want to just unmute themselves and ask, that's fine as well. But otherwise, a lot of love for you here. Well, if there aren't any other questions, I guess we can let everyone go a little early. Oh, here we go. Got some more. What was the cost per square, I'm assuming foot, for Rockwood?
The cost per square foot for Rockwood, well, I always hate giving cost per square feet because it changes so fast lately.
Yeah.
But it was, and I don't have it on the top of my head, but it was in the low 200s or something like that.
Okay. Was there a structural connection between the topping slab and the CLT panels?
Yeah, the topping slab, there's no structural connection because it is, and it was a little bit, yeah, it has nothing to do with the structure. It's really just a house. It's to be a thermal mass for the hydronic system. There is, I didn't show it, but there's quite a strong structural connection between the walls and the floor panel. And that's basically, it's a 4x6 or a 4x4 angle that's screwed to the walls and screwed to the floor diaphragm that connect the walls to the floor diaphragm. And then we use that 4-inch kind of the edge, that top edge of the angle as a screed point for the concrete. So they basically poured right up to the top of that angle. So the angle creates kind of a nice, we don't have any base trim. It's a very kind of primitive building in a way. And so there's no base trim. So the angle created a nice transition from the floor to the wall, CLT wall.
Since you have been living and working in the building, what have you learned or what would you do differently? And what's the most surprising in your mind?
Well, to start off, it's always hard to live and to work in a building that you designed because you're like stuck with all the mistakes forever. So that part's hard. I think like one interesting thing, so this wood innovation grant's really great because it's helping us sort of put together analytics about what is working well and what's not working well. I think one interesting thing is from an energy point of view is how to connect CLT wall panels together. And we found that this half lap works really well. So we're losing kind of negligible energy through the half lap. In contrast, in the corners of the building, where we have two, and the wall panels, they're 5-ply, so it's like 6 inches of wood thickness, and those are butt joints, so they're butt together and screwed together. But as the wood, climatized or dried out, it naturally just moved and shrank, and so in some places it's not really perceptible. In other places it's a little bigger, but even the imperceptible joints, we found that they're leaking, maybe not to a great extent, but leaking energy. And so we're using this Wood Innovation Grant to we'll find out what's working, what's not working, and then what's not working, kind of come up with like, well, if we were to do it again, what we would do. And so whether it's a half lap at that corner joint, or whether we have some sort of gasket, or we're using sealant. I mean, we tried not to use sealant in the building, but those type of techniques.
Let's see, what was the thermal value of the exterior wall construction? I mean, I'm assuming we're still talking about.
Yeah.
You guys
that's a really interesting question, and I don't it's not a simple answer either. And it's also it also gets into the potential of mass timber just behaving differently when it comes to R values. And Mark Fretz, actually, in his group at the U of O, they just recently received a grant that's, I mean, for us, it's kind of like a next step to our kind of analyses, and they're building a generic box that they can, a more controlled box, and they'll be able to, the idea is they're going to be able to kind of define that for mass timber, but also for mass plywood, and come up with an R value, but also kind of show how a mass timber wall behaves differently than other wall assemblies. I mean, with that said, it's from a city's point of view, it's at least an R21. But if we add up the wood, we have, I didn't mention, I guess, so it's the 6 inches of wood, mass timber, and then we have WRB, and we have 4 inches of rock wool on the outside, and then the metal. So it's the wood and the rock wool together.
So this one looks like a clarification. Okay, let's do this one first. Question was for Mississippi. And I am assuming that the thermal efficiency is much better with all continuous exterior insulation.
Yeah. Well, the air sealing, like the great thing about this sort of tilt up technique is that nothing is getting through the wall panel, like a 5-ply. No air is getting through that. It's really the half lap, but the half lap is really performing well. And so from an energy point of view, the generic wall is doing really great. It's really the corners. So how to improve the corners.
And then there was I think this was a clarification of previous questions. So the topping slab ended up being 4 inches total? I thought it was 5.
4.
It was 4?
Yep, 4.
Okay. So yes. And that looks like the end of the questions, which is just about on time, so that works great. Thank you so much for this, Ben. This was great. I just wanted to clarify to everyone that these two projects both won citation awards in 2022, because we didn't clarify that. And if there are no other questions, I will say goodbye to everyone, and thank you again for your presentation, Ben.
My pleasure. Thank you. Thanks, everybody, for attending.
Thank you.
Bye.